Hello everyone, Dr. Chen here. So in this video, we're going to discuss the relation between linear motion and rotational motion. And more importantly, we're going to introduce the concept of centripetal acceleration. So let's look at this particular scenario. So we have an object rotating with angular velocity omega. So we find a point P on this object, which is with distance r from the rotation axis. So the rotation is happening this way. P is rotating in a circle which is r from the rotation axis. So the angular displacement of P from 0 angle to theta angle is theta x. So angular displacement is theta s over r. So what is the tangential velocity of P for this rotation? Tangential velocity would be the velocity of P, which is tangent to the known everywhere. So we can use our common sense to kind of figure out if the angular velocity is a constant. So v is the speed of v, which means the magnitude of velocity should also be a constant and always tangent to this circle, right? Okay. And this is our omega, right? Average omega, which is the angular displacement divided by time, and angular displacement is the s over r. We just bring this r to this side, 1 over r. So delta s over r gives us delta theta divided by delta t. Now we do know what is delta s over delta t, right? Delta s over delta t would be the velocity. So we find out the relation between angular velocity and tangential velocity. Angular velocity is tangential velocity divided by r. So on the other hand, of course, tangential velocity should be given by r times omega, r times angular velocity. Tangential velocity equals r times angular velocity. Tangential velocity equals to the distance from this point to the rotational axis times the angular velocity. So this is our first conclusion. So we can relate the kinematic variables of angular rotation to linear motion. Tangential velocity. Now, this relation we found out. Tangential velocity equals angular velocity. So apparently change of tangential velocity should equals to r times change of angular velocity. And then we divide by delta t on both sides. We're going to arrive at this equation now. What is delta vt over delta t? I think you can figure it out, right? It would be tangential acceleration. The acceleration of this, the acceleration of this point along the tangential direction, at. And what is delta omega over delta t? What is delta omega over ft? We just discussed in the last lecture video. Change of angular velocity divided by delta t gives us angular acceleration. So we arrive at another important conclusion. Tangential acceleration equals r, which is the distance from this point to rotational axis times angular acceleration alpha. Tangential acceleration equals distance from the axis of rotation multiplied by angular acceleration. So we arrive at two important equations. Tangential velocity equals r times omega. Tangential acceleration equals r times alpha. Example. So we have a helicopter. We know its angular speed, and we know its angular acceleration. We want to find out for point 1, this point, which is with the distance 3 to the rotation axis. What will be the tangential speed and what's the tangential acceleration? So first we need to find out what is the angular speed in radians per second. 6.5 revolution per second. One revolution is 2 pi radii, 2 pi radians per one revolution. 2 pi radians per revolution, this gives us 1. So revolution and revolution is going to cancel. We plug in pi equals 3.14. We find out that the angular speed is 40.8 radian per second. So this is wrong. Tangential velocity equals r times angular speed, which is 40.8 radian per second. Plugging all the numbers, we find the tangential speed is 122 meters per second. Now, calculate tangential acceleration. We need to convert angular acceleration to radian per second as well. Angular acceleration 1.3 revolution per second square. 2 pi radian equals 1 revolution. We find out the angular acceleration is 8.17 radian per second square, and angular acceleration is distance from this point to rotational axis, which is 3. Angular acceleration, answer is 24.5 meters per second square. This is tangential acceleration. Okay. Now, if omega is a constant, we should conclude that omega is 0. So angular acceleration is 0. So if omega is a constant, we don't have tangential acceleration. Only if alpha is not 0. Only if alpha is not 0, which means angular velocity is changing, we have tangential acceleration. However, even if this object is doing a constant omega motion, so omega doesn't change. So what's the acceleration on this car if the car is driving at a constant speed along this circle? Is it 0 or is it not 0? Is the acceleration 0 or not 0 in this scenario? So we have to think about Newton's first law. So if acceleration is not 0, then velocity doesn't change. Now in this case, the car driving at a constant speed along this circle, speed doesn't change, but the velocity does change because the direction of the velocity is constantly changing. So even for constant angular speed motion, there is acceleration because the direction of this tangential velocity is always changing. And we call this acceleration centripetal acceleration. Now our job is to find out what's the magnitude. First of all, it's just the definition of acceleration. Acceleration should be calculated as change of velocity. And in this case, magnitude doesn't change, but direction change. And using Mathematica, we can find out that the magnitude of this acceleration is v squared divided by r, which v is the speed of the car, driving constant speed along the circle. And the direction of centripetal acceleration should be always pointing to the center of the motion, the rotation axis of the motion. There is a proof on your textbook why it should be v squared over r. If you are interested, you can go read the textbook for the proof. But for this lecture, let's just go to the conclusion. For centripetal acceleration, which exists for every rotational motion, is equals to v squared over r. So as long as there is a v, as long as there is r, so as long as the speed is non-zero, we should have centripetal acceleration for rotational motion. And its magnitude is given by v squared over r. And this v should be tangential speed, the magnitude of tangential velocity. Okay, and we just learned tangential velocity is r times omega. So we can replace v by r times omega. And so centripetal acceleration can be calculated in using those two expressions. Tangential speed squared over r, or r times omega squared. They are equivalent. Using which one to calculate centripetal acceleration depends on what the programs give us for the values, right? The distance from the point to rotation axis is a length, so its dimension is length. Angular speed unit is radian per second. So a radian dimension is 1, so angular speed is dimension is 1 over t. Centripetal acceleration, we can find it out from here. The dimension of r is L, dimension of omega is 1 over t, so centripetal acceleration is dimension is length over t squared. It's just exactly the same dimension as we learned before for acceleration. Acceleration is L over t squared. Look, now we have two accelerations for rotational motion. This is the rotation axis. And we have an acceleration which is at, which is tangential to this circle. And we have a centripetal acceleration which is AC, pointing to the center of the motion, which is rotational axis. And they have an angle. And they are both acceleration. So they should add up as vectors. This is our total A. So the total acceleration of an object doing circular motion that has an AC and also have an AT, which is tangential acceleration, its total acceleration should be calculated using Pythagorean theorem to add those two accelerations together as vectors. So the magnitude of this A in this direction, magnitude is AT squared plus AC squared, then square root. Now remember, for every rotational motion, we always have AC. AC always there. The tangential acceleration, is it 0 or non-zero? It depends. It depends on whether the angular acceleration is 0. In other words, does the angular speed change? If angular speed change, then AT is not 0. Angular speed doesn't change, AT is. If angular speed does change, AT is not 0. Angular speed changes, AT is not 0. And then for AC, as long as there is rotational motion, AC is not 0, and it equals to v squared over r. And we call the force, which causes centripetal acceleration, the centripetal force. So in this example, we have a kind of a disk attached to a string doing rotational motion. So this is T pointing to the rotational axis, and this T will provide the centripetal acceleration. And Newton's second law would tell us centripetal force should equal to mass times centripetal acceleration equals mv squared over r. Now for satellites, for anything that is orbiting around the Earth, the only force acting on it is gravitational pull from the Earth. So the Earth will provide a centripetal force that maintains this object to do centripetal acceleration around the Earth. And that's how this object becomes a satellite of the Earth. So how do we solve problem with centripetal acceleration? We need to find out the net force on this object. We need to do free body diagram. We find all the forces acting on the object. We add them together as vectors. And the net force should always equal to m times AC, v squared over r. So we should draw a free body diagram of our object, choose the coordinate system, find the net force, which should be always pointing to the rotational axis. And Newton's second law tells us the net force should equal to m times AC. And for us, usually, we use this one. And the problem we have usually has tangential acceleration to be 0, acceleration in the perpendicular direction 0. So this equation is more important for us. And then we solved a unknown variable from this equation. Okay. Example, a discus thrower. Starting from rest, initial angular velocity 0, throw the accelerate to a final angular speed, 15 radians per second, time 0.27. And the radius is 0.81. Find the total acceleration. So in this case, we have a centripetal acceleration, which is pointing to the rotation axis. And we do have a tangential acceleration because angular speed changed from 0 radians per second to 15 radians per second. So we need to calculate AC and AT, and then we can use Pythagorean theorem to calculate what is total acceleration. So AC can be calculated R times omega squared. So this one would be easier for us to calculate because omega is already given. Radius 0.81. Omega, final omega 15 radians per second square. Give us the centripetal acceleration is 182 meters per second square. And then we need to calculate what's the tangent. What's the tangential acceleration? Should be equals to radius times tangential angular acceleration. Angular acceleration is final angular velocity subtract initial angular velocity divided by time. Plug in all the numbers. Tangential acceleration is 45. And then total acceleration is tangential acceleration square plus centripetal acceleration square root. Plugging all the numbers we find is 187 meters per second square.